Thank you. Appreciate you guys coming after lunch. So I've got a couple of objectives for today. The first one is to not put you to sleep, right? So you just filled your stomach, so I'm going to try and make myself at least interesting enough for you to stay awake after filling your stomach. Okay. The second, though, is we're going to try and talk about what it means to design for safety and security in the context of connected and autonomous vehicles. Now, I'm not going to go our conventional route this time. I don't want to talk about bits and bytes. I'm not going to necessarily talk to you about detailed technical execution. Actually, what I want to do is I want to go a little bit more conceptual, and I want to go a little higher level. I want to take a look at why safety and security is so relevant in automotive and how we can help the industry to approach it. So my background, my name is Marcus McCammon. I'm the Vice President of Automotive and Connected Vehicle for Wind River, but I come from the OEM. Okay, so what I want to talk about is how we look at the technology from the OEM's vantage point to help them to understand how to migrate into the technology and, quite frankly, to make a better business for ourselves. Okay, so first and foremost, I think we have to give some context, right? So over the past 130 years, we've seen the industry evolve from the Model T to, I think, the Model S is a good example of where we think the automobile is today and where it's going, right? Very much software defined, very technological features that move kind of on a consumer products timetable compared to a very staid product, very simple, you can kind of get it one way, right? So when we talk about the marriage between these two, though, this is the thing that's interesting. Henry Ford's goal was to mobilize everyone. Okay? That was his stated purpose. He wanted to give everyone the opportunity to move from one place to the next, thinking that it would help boost, bottom line was to boost socioeconomic progress. Well, when we talk about what we want to accomplish with connected and autonomous vehicles, the target is exactly the same. In many ways, we're still trying to realize the promise that Henry Ford gave us, like I said, 130 plus years ago. Okay? But this transformation that we're seeing, we saw 130 years of evolution in the automotive industry. In the next 2 to 3 decades, we're going to see revolutionary change. Okay, and I want to talk about how that folds into what we do. So first and foremost, connectivity. So connectivity is relatively new for us in the industry, right? It largely took hold in about 2003 to 2005. You know, depending on which one of the OEMs you grab onto, everyone was saying that they were first, right? OnStar is probably a good example of one of the first real connectivity pushes that we saw from the industry. But by 2025, most analysts believe that connectivity at some level will be ubiquitous. And I'm not talking about tethered connectivity, bringing your phone into the vehicle, but native embedded technologies inside of the car that allow us to make use of the terabytes of data that have been existing in the car for eons. Okay? So the next one for us is electrification. Again, electrification is not new. Many people don't realize this. In 1902, about 80% of the vehicles that moved around the streets of New York City were electric vehicles. Okay? They were primarily used for debutantes and heiresses because they didn't want ladies to be outside draped with the smell of gasoline as they were cranking their engines to get them started. Now, it disappeared and then kind of re-emerged back in the 90s. But what we see now in electrification is the opportunity for us to take advantage of more simple design and powertrain systems, more simple ways to maintain and support your vehicle over time, and then also the opportunity to use software and hardware to increase and introduce new experiences over the vehicle's life cycle. Today, we can't do that. Okay, and then lastly, of course, everybody wants to talk about autonomous. Now, depending on who you're talking to, autonomous is going to take over the world tomorrow. Most likely, we have a few years in front of us. But the promise of autonomous is really the promise that Henry Ford promised us so many years ago. Okay, it is the idea that we can have mobility without loss of life. Number one. Okay, the second is that we can connect people who are otherwise not connected. Young people, old people, people who are disadvantaged, can't afford to buy a car, have a difficulty getting the public transportation. They can now make it to the other side of town and give themselves a job and make more prosperity for their family. And then last but not least, for many of us, is the opportunity to gain productivity, gain back use of valuable time that's often lost just in the time that we spend in the vehicle. Okay, now when we think about this in the context of the business, okay, many of these features that are going to drive into the connected and autonomous vehicle are going to be defined by software, right? Depending on which analysts you look at, there's a high and a low case, that the software could account for as little as 33% of the market value of a car, as much as 50%. Okay? Now this is a conundrum for a person from the conventional automotive industry, because I can't touch it. I can't wrap my hands around it. I can't put it in a dynamometer and run it until it explodes, because the software is not going to explode. It's not quite that predictable. Okay? So what that means for them is that what comes next is critical. Because if you believe Price Waterhouse, Bain, Boston Consulting Group, Bain, all these guys say that mobility as a service, mobility on demand, is going to be the next big economic revolution after the mobile phone. $1.5 trillion is the estimate. Today, the automotive industry accounts for about 2.5 to 3 trillion, so that's about 3 to 4% of the GDP of every developed nation. Okay? So we're talking about another half again on top of that. So this is a big transformation that we're a part of. Now, if I look at it from a business perspective, today the business case is pretty simple. My opportunity to harvest money is upfront. I deliver a vehicle, I make money, and then as it goes forward, my opportunity declines. Right? I am service and maintenance, and quite frankly, most of us in the tech sector don't participate in that as much. Okay? Now, in the future, the model is that after the vehicle is deployed, there's opportunities to continue to re-engage with the customer, update the value proposition, basically recreate a vehicle as it stands after the person's already taken ownership. Okay? It's a completely different construct, something that is more familiar to us in consumer products, but is completely foreign to the automotive industry, and frankly, they've spent 100+ years optimizing the way that they do it. Now, the issue is risk exposure. Okay? So, because the same way that the opportunity goes down, the risk exposure goes down in the current model. I build a vehicle, I give you a warranty. When the warranty is over, I'm done with you. I'm not worried about some changing of software, things being manipulated. I'm done. I try and sell you another one, right? Even though you don't need that 2020 model year, I'm going to convince you to buy it anyway. Well, in the future, all of this new promise, all this new money is also coming with new risk, and the risk is unbounded. They don't know how to quantify it. So I can tell you any automaker on the planet can predict to within a month of when their powertrain is going to fail. They're that accurate. Okay? The simulation and the real world testing has been correlated with that great a detail. Now, I'll ask any of you guys, how many of you can predict when the next bug will come in your software? If you can do that, you need to take over this place. You're rich. You need to go retire somewhere, and I will come work for you. I'll be your valet or something. Okay? So we have that challenge. It's something that we know how to manage it. Now we got to introduce this to an industry that's used to working in hard parts. So in the modern era, the request of software is that it be safe, secure, certifiable, scalable, available, interoperable, resilient, portable, compliant, blah, 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 blah. An image of a unicorn comes into mind really quickly, okay? But for the sake of the discussion today, I'm going to focus on the safe and secure, because this is a very real challenge. So the benefit that I have, and I enjoy being in this role, is I spend a lot of time with senior executives at the auto companies around the globe. All of them are wrestling with this. I want cake, and I want to eat it too, and I want you to iterate it faster than you ever did before. But I really don't understand what that means. But if I don't figure it out tomorrow, then I'm going to be out of business. I really want to play with Google, but I'm afraid Google's going to take over my business. Right? I really want to make cars autonomous, but I actually have no idea what the risk profile of that is. So let's try and explore it for a second. So first, today we talk about the in-vehicle network. So inside of the vehicle, I don't know if most people realize this, but the second heaviest component in a vehicle after the engine, and I'm not counting the body, after the engine, the second heaviest component in the vehicle is the wiring harness. Okay? So the network inside of the vehicle is a very, very intricate thing. It's comprised of anywhere between 75 and 150 independent control units, right? We all know that. We make money off of that business, okay? And mapping how the software moves from one side of that is really an isolated discussion. The powertrain guys worry about the powertrain issues. The body controller guys worry about the body controller issues. And as we're adding new features with ADAS, autonomous, and connectivity and electrification, what they're wanting to do is move faster. So that means that we're going to go from closed compute, your classic AutoZar, bare metal computing, things that work on small microprocessors, microcontrollers, and we're gonna move into more open controls. Okay, we're going to bring more open source software into the market. We're going to be leveraging IP from universities and from startups and from stalwart tier ones, and we're going to put all that together into one big bowl of soup. And ultimately, we're going to try and deliver it to the customer and guarantee to the federal government that we won't cause loss of life. But the reality is that in connected and autonomous vehicles, the system is much broader than that, because if we put all of the onus on the vehicle for, say, an autonomous driving use case, then the cost of that autonomous vehicle will be so prohibitive that none of us average people would ever be able to buy it. So we need to consider fog computing, near-field communications. Today, the industry is talking about DSRC. Tomorrow, we need to talk about 5G, or at least cellular V2X as a bridge. We need to have infrastructure involved in the discussion so that we can offload some of that high-powered compute into municipalities. Imagine what we could do to the cost profile of a vehicle if I had LiDAR at every street corner and I had V2X to allow that LiDAR to communicate to the vehicle so that it could do a profile. Now, for us here, that should mean more opportunity, because now I'm not just selling to the vehicle, but I'm also selling to the infrastructure that supports the vehicle. I don't know about you, but right now I don't sell software into the concrete companies, okay? But in the future, processors in and around your infrastructure is a very real thing. And then of course there's the cloud element, and all of us have great ideas about how we address the cloud. But the point of all of this is that for the automaker, the system that they have to secure is all of it. Because all of those present an opportunity for a new threat vector. And all of those new threat vectors have to have access to the vehicle. Otherwise, we can't realize the value that they present. So I've got more systems that have to access the vehicle. Each one of those systems is available to a threat, and I have to contemplate all of that in the context of my vehicle design and vehicle architecture. This is what we're going for, okay? I don't know about you guys, I have 3 little ones. And at some point in time in the not too distant future, I'm supposed to take my 3 little ones, let them walk outside with a vehicle that shows up as a robot, have them climb into it, take them to wherever they want to go without me being present, and trust that someone's not going to take control of it and send it into some catastrophic outcome. So the stakes are high. So the first thing that I want to emphasize is that when we start talking about cybersecurity in this kind of context, it's not just security, okay? Security and safety are wedded. So when we talk about safety, we say the system must not harm the world, okay? Certified systems, safe systems. I know that when this piece fails, I know how it's going to fail, and I can predict what the outcome is so that I can put a countermeasure in place. That's generally what we're talking about. At Wind River, we've got a great legacy. We've been in business for just under 40 years. We've been doing safe certified systems for 20 years, okay? And frankly, we've been doing safety systems for the entirety of our existence. Now, when I talk about security, what I'm saying is that the world must not harm the system. Okay, so I want the system to interact with every element of the world, but I don't want that world to be able to interfere with the way that the system operates. It needs to be predictable. I need to know what the outcomes are. It's interesting when we start talking about the introduction of artificial intelligence. What if I could if the artificial intelligence system operated exactly as it was intended to, but I could give it precisely accurate behavior that was false? So you sense something, the action that I want you to take is to turn. I want you to turn in this moment, but I tell you to turn in the opposite direction. So it sounds like a very simplistic case, but I had a conversation with the CTO of one of the largest tech companies in the world, Big Blue, 3-letter, the guys used to do the blue suits. And he said the notion of introducing false positives into an artificial intelligence system is extremely real. You will see no failure. There's nothing that says that the system performed improperly, but the outcome is wrong. So the beautiful thing about safety is it matures and gets more stable over time. The more that we test it, the more that we put it out into the field, the better we understand how it's going to perform. Security becomes more challenging over time. And if security and safety are now wedded, that means safety is going to become more challenging over time. So everybody has beat to death the poor Jeep guys. And I feel bad because I used to work in Jeep engineering, right? So when the whole Jeep hack came out, and everybody was like, Jeep sucks, you're terrible, Chrysler's the worst. And so I was feeling for some of my friends over there, right? But it's a very, very real scenario, okay? And frankly, if your consumer is demanding that you get more feature content every single day and in every single season, every model year, if I want to buy a car today and I want the car to feel new tomorrow because someone got a new feature, I want to give you an update and give you some new feature content, that update might have introduced new risk. Okay? So trust me, I'm going somewhere with this. So this is when I was at Chrysler and I had the ability Chrysler, Daimler, then I supplied to Ford, I supplied to Toyota. This is the way we did development. You did body engineering, chassis, interior, electrical, powertrain, and we all focused on our silo. It's the way we got things done. And then someone started talking to us about cybersecurity. Well, then we took cybersecurity the same way, down the silo. But the question for the future is a design approach that has to go horizontal. Okay, so, all right, Marcus, where are you going with all this? We're supposed to be talking about cybersecurity and safety. Okay, well, here's the point. Here's the point. If I'm looking at cybersecurity and safety as independent silos, as independent channels in my design process, then I will always be flawed. I will always be flawed. Now, why is this relevant to us? Well, as we're selling into the automotive industry, one of the things that we have to challenge our customer to do is up-level their viewpoint in their conversation. We need to have them take a systems level perspective. Now, at the end of the day, I might be selling them a part just for chassis controls. That's okay. But the conversation that I want to have with them initially to drive to that is a conversation about how what we do in chassis controls will impact the overall system. So we like this guy, Conway. Conway's Law. Real simple. If you build an organization that's siloed, what comes out will be siloed. So I submit when I go around and talk to my OEM friends and customers that every last one of them now has vehicle systems that are innately vulnerable. Okay? Now, they're buying some of the best and latest and greatest technology from all of us, and we're all doing our best to make sure that the systems we sell them are safe. That's true. It's not our fault. It's the fault of the fact that we view the architecture of the vehicle as a collection of pieces as opposed to one holistic system. And then, like I said before, the next challenge is to look at the system as it extends past the car, and what do we have to do to secure it there. So I was having a conversation with someone last week, and we were talking about key management. And they said, well, when the vehicle leaves the assembly line, then we're going to assign the key, and then we have that secured, and the key is tied to the entire car, so we have the whole car system contemplated. Okay, so my question to him was this. The software that's in your window, in your body controller for window controls, when was that created? I don't know. Who created it? Well, I got it from this tier one. Did that tier one outsource the development of that software? Or did they do it in-house? I don't know. How long have they been using that same code? Well, I don't know. It's we're reusing a part off the shelf to drive costs down. We got some efficiencies year over year by reusing the same content. Okay, great. Tell me this. Did they use a security design lifecycle process when they wrote that code? I don't know. It's just a window regulator. Okay? So that was one very simple example that I gave him. Now I said, let's go across every ECU you have in the car. You have 150 of them. Across each one of those ECUs that you have in the car, can you trace, what is it, 23andMe? I want the 23andMe genealogy of the software of every ECU you have in the car so that I can tell you whether or not your car is actually safe. Nobody can do that. Nobody can do that. But as we look forward and we start planning for autonomous vehicles, in order to secure that system, we have to have that kind of a construct, some sense to understand where the bits and pieces come from. This is the conversation that we should be engaging our customers with. Every OEM that I know, every senior executive that I know is contemplating or in the process of restructuring their engineering and development systems to try and figure out how to look at their business horizontally. The problem that they have is they spent 130 years optimizing the silo. So the challenge for us, or maybe the opportunity for us, is to go into them and show them how we can introduce systems thinking. So for me, I'm not the smartest guy in my team. I always tell my chief architect, you're way smarter than me. I'm the dumb guy that carries your books around. Okay? So everything to me I have to break down into simple terms. But I look at our security and safety in three basic pillars. The first is architecture. And if you notice, I've been spending most of my time talking about that. Okay? Architect your system for the anomalies that you don't understand tomorrow. Okay? Building a structure that recognizes that the cycles of validity for your hardware, for your silicon, is different than the cycle of validity for your operating system. That's different than your middleware. That's different than the applications that you want to introduce to your customer. Okay? And build the system such that we can interchange those parts and pieces and identify and trace and track the changes that we make. The next is process. Okay, so the easiest one to talk about is the software development process or security development lifecycle process. Okay, to have a documented and stated process for how we approach security. So the beautiful thing in automotive, we have a process for everything. It usually has a 3-letter acronym, and it's usually incorporated in about 500 pages of PowerPoint slides. But if we took the same approach that we take to ISO 26262 for certification of safe systems, where we document failure modes, we document the mitigations. If we apply that same methodology to the security systems in every one of the components that we have inside of our vehicle system, now we've given ourselves a construct for a truly securable vehicle. Now, that implies cost. The OEM can't stomach all that cost. Quite frankly, they don't understand it. It's in too many places. It's too many moving parts. I mean, just look at the number of tech companies that the OEMs have acquired over the past 5 years. They are doing those acquisitions to learn what they don't know, but we have the ability to provide that education. From us to bring the safety and security process to the table, we can take that concern off of their table and allow them to focus on where their value is created. Lead with it. I had a conversation with a former automotive CEO 3 weeks ago. And he said, and I told him, I'm really proud of our team. When the OEMs come in and they want to audit our quality and safety processes, we've got all of our documentation ready. He said, you're wrong. What do you mean? He said, don't wait for them to come and audit you. Go tell the story. Show up and invite the audit. Show them the safety documentation, the security documentation for the product that you've created, that your processes are already in place, because frankly, they don't want to have to care about it. They've got too big of a hurdle just understanding what in the hell that chip was that you sold them yesterday. Okay, that makes sense. And the last pillar that I consider is tooling. Now, tools for me in my business is everything from the way that we build our operating systems and our virtualization profiles, all the way out to the notion of being able to update our software over time. Contemplating the fact that no matter how good we are and how smart the team behind me is, we won't answer every question correctly. So plan, what we used to say when I was in Detroit, we'd say plan for our own obsolescence. Okay, have a construct in place that your system must be updatable from day one, and that's whether you're talking about hardware or software. Okay, and I'm not talking about the questions that are existing in the purchasing office and the low-level engineer, but this is the question that the CEOs of the company are asking themselves as they face down the challenge of cybersecurity and safety. And I'm not making it up. This is what they told me. Okay, now from my vantage point, and I got to give you the Wind River view. Okay, what we try to do is leverage everything that we've learned over the past 40 years. We have the benefit of exercising our business in the networking industry, in the aerospace industry, in the defense industry, in the medical industry, in the industrial industry. And we are aggregating that learning from all those industries to see how they have approached safety and security and see what we can leverage back into automotive. So one of the things that we learned is this construct here. We call it the three-layer decoupling. Okay, so most of you guys are a lot smarter than me, say, yeah, no brainer, I got it. But the concept is to recognize that every component of our software system has a different life cycle. And instead of trying to mask the fact that they have different life cycles, but it's to plan for enabling the life cycles to be articulated at different points in time. What the OEM really wants to do is put their focus up top in the yellow, because that's where they can see a direct return on the investment that they made towards their consumer. At the end of the day, remember, this is a consumer industry. They're not a tech industry. Not a tech industry. They are experience companies. There's a reason why the Mustang exhaust note has a particular sound. There's a reason why a BMW closes and has a particular sound. It's part of their brand experience. That's what they know how to do. That's what they want to focus on. Our job is to take some of that other stuff, some of the other challenges away. So what we do is we build a framework. Our framework contemplates the use case and safety and security from the cloud all the way through to the device. And we provide them a basis of safety and security much the same way a spine runs up the center of our backs and holds us up. Because without that foundation, a house built without a strong foundation is just a collection of sticks. So to get to that, what we're leveraging is our legacy. So I've got an interesting challenge at Wind River. We have the benefit of being number one in real-time operating systems across all the markets in which we serve. We have the benefit of being number one in commercial Linux across the markets that we serve. And I want to take that same benefit and translate that into the automotive industry. To do that, I need the help of the rest of the people here at this conference. We have to collectively get together and align ourselves on system thinking so that we can help the OEMs speed to the transformation at the rate that they want. Otherwise, what will happen is when we see the next economic downturn, they're going to retrench because they're afraid of the cost and challenge of the change. If you don't believe me, go back and read your newspapers from 2005 when we first started talking about how fast electrification was going to come into the automotive industry. See what happened when we had the economic downturn and everybody went back to gasoline internal combustion engines. And now we're trying to watch that slope come again. We have a great opportunity in front of us with connected and autonomous vehicles, but it's up to all of us to enable it to happen. And we have to do it by looking at safety and security from a holistic standpoint. So with that, I leave you with this one thought. When it matters, it runs on Wind River. And I hope that I get an opportunity to talk to you guys here this weekend and we can forge partnerships that help us to drive success. And I thank you very much for your time.